This is the third part of lesson 8.8. So continuing on, number 7, we've got another proof. And so you look at this, which is the more complicated side? Hopefully you're seeing that this side on the left is more complicated. Okay, so we're going to work on making that look like what's on the right-hand side. Do not do anything to the right-hand side. Don't write it in terms of sine and cosine. Just leave it alone. Okay, so starting over here, I look at my 2. I'm adding fractions. That's what it says to do. So what do you know about when you add fractions? What do you have to have? We have to have a common denominator. So if I look at my denominators, I'm going to have cosine theta, sine theta. That will be my denominator. So to get that, I'm going to multiply by 1. So I'm going to have to multiply this one by sine theta over sine theta. And I'm going to have to multiply this one by cosine theta over cosine theta. So what this one turns into is sine squared theta over sine cosine. And then this next one is cosine squared theta. Okay, so I always find that students at this point, they want to go cancel, 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 and do something. That's not something you can do because of the plus sign. Sine squared is not a factor, it's a term. So remember what you've learned about that. So think back to what else do you know? What else could you do? What else could you substitute? Equal values, things like that. So pause the video and see if you can think of it. And if you can't, or if you can, come back and we'll continue. Okay, did you think of the Pythagorean identity? Sine squared plus cosine squared, that's equal to 1. So 1 over cosine theta sine theta. Now keeping in mind that I'm trying to get there, look at this. How about if I separate that into 1 over cosine theta times 1 over sine theta? I can do that because that's how you multiply fractions, is you just multiply the top and the bottom. So that is something I can do. And so 1 over cosine theta is secant theta, and 1 over sine theta is cosecant theta. And so commutative property says that it is the same thing as, secant theta. And so what I've just done is I've proven what I needed to prove. Okay, number 8, we're going to prove this whole thing. Before we do, let's review a couple of things. One thing in the last module that you learned to do a lot of is a lot of factoring. And so when you factor things, you need to think of, how do I multiply these factors together to get my final answer? And we're going to be using that skill right here. But you look at this problem and you might think, I don't know how to factor that. So one strategy that we use in higher math is we use a substitution, and we take a very simple variable and we replace it with something else just to kind of hold the place. And so we're going to do that in this problem. We're going to let x, for just a minute, be equal to sine alpha. So we're just going to let x hold the place for sine alpha. So let's rewrite our numerator. Instead of sine alpha, we're going to write x. Instead of sine squared alpha, we're going to write x squared. Okay, so let's just focus on that for a minute. We're not going to look at any other part of the problem. Let's just look at that. Now, we already know from long ago that that is the same thing as that. So if this was in the last module that we did, and I said, hey, what are we going to do with that? You would factor it. So factor it. So we're going to take that and we're going to have x plus 1 times x plus 1. So now let's go back and let's put back what we replaced. So we're going to go back to, instead of x, we're going to write sine alpha plus 1, sine alpha plus 1. So we just let x hold the place for it until we could get back to that. And then cosine squared alpha like that. Okay, so now I'm going to look at, what do I know now? This one's pretty hard to see because you look at this and you might think, well, I need to multiply that, but then you're back to where you started. So if you distribute, that doesn't help you because then you're right back where you began, so not helpful. And you look at where you need to end up, and that's looking pretty unfamiliar. So you really have to dig deep on this one. Think of what is in this expression that I know something else about. So the sine alpha plus 1, I can't do anything with that because you can't replace it with x because that's just a placeholder. You can't multiply it back together because then you're back where you started. So look at your denominator. Cosine squared is one of your basic trig identities, and so you can't, or ratios, and so you can't replace it with anything. Replacing it with 1 over sine isn't going to, or 1 over secant isn't going to help. So think of what else you know. What did we learn at the very beginning that I said was really the only new skill in this whole lesson? So solve this for cosine squared alpha. And this may be something that you wouldn't have thought of, and you might think, I never would have thought of that. Well, maybe you wouldn't have yet. But you start getting used to things like, well, what else can I replace it with? So instead of cosine alpha, what if I write that? So I'm going to write sine alpha plus 1 times sine alpha plus 1 over 1 minus sine squared alpha. Okay, so it looks promising because at least we just have sine now, and I know that that's where I need to go. So we're back to, well, what else can I do? What else do I know about this? And so again, we're kind of at a dead end on the top, so think about on the bottom. Let's go back to that substitution idea where we let x equal sine alpha for just a second. Let's do that on the bottom. So instead of 1 minus sine alpha, what if I did 1 minus x squared? So go back and think to what you've learned. How could you write 1 minus x squared? How could you do something with that? And so if you remember 1 minus x squared, actually pause the video and see if you can think of it. Maybe you thought of difference of squares. So difference of squares, remember, is when you have something like x minus 1 times x plus 1. We saw this a little earlier in the lesson. And you have your middle terms cancel out. So plus x minus 1, and those cancel out. And if you look, what we have right here, the 1 minus x squared, I could factor that. Now go back and put back your sine squared. Let me rewrite the whole thing. So I'm going to take I'm going to take the numerator and write that again. We don't want to lose track of where we are. Okay, my denominator, this part, I factored it. And now I'm going to replace back the let x part. So it's going to be 1 plus sine alpha instead of the x now, and 1 minus sine alpha. Now, what can you do? We're looking at 4 factors. About 1, 2, 3, 4 factors. So what can you do with factors? You can cancel like factors. Sine alpha plus 1 is exactly the same as 1 plus sine alpha. Those can cancel. What are you left with? You're left with, on this top one, commutative property, addition. And that is what we were trying to prove. So this one's definitely the hardest one of all the proofs in the notes part of this lesson. And you might have 1 or 2 challenging ones. If you're not being challenged by this assignment, then I'm not doing something right. But you're going to have a couple where you're going to have to think of factoring and maybe substituting something in. So just be on the lookout for that. Okay, the last one we're going to do is we're going to simplify the square root of 25 tangent squared beta plus 25. So before you get too excited that this is an easy one, let's go back and talk about some basic ideas. When we talk about the square root of 16 plus 4, what's that equal to? Hopefully you said square root 20. Is it equal to the square root of 16 plus the square root of 4? Nope. It's not equal to that. Addition is not the same thing as if we were multiplying. If we were multiplying square root of 16 times 4, then that's equal to the square root of 16 times the square root of 4, but not if you're adding. So adding is different than multiplying. When we're looking at this problem right here, we are looking at exactly the same thing. So don't write this down, but what a lot of people want to do is they want to take the square root of this piece and the square root of this piece and just say, there's my answer. And that is very, very wrong. Because of the addition, you cannot do it like that. So we have to think of something else. So let's just look at what's inside. Can you simplify what's inside? Can you rewrite it in some way? So you might want to think about that substitution strategy. Let's let x equal tangent theta for a second, or beta, sorry. And so if I wrote 25x squared plus 25, how could you rewrite that? Did you think of a GCF? Taking out a greatest common factor, so we could have this. And so it's still under the radical. And so what I've got now is I've got 25, and then instead of x squared, I've got tangent squared beta plus 1. Okay, now that I've got one factor times another factor, I can separate my square root. So I can say square root of 25 times the square root of tangent squared beta plus 1. So I can do that part. So I'm going to leave the 25, the square root of 25. Let's just hang on to that. Let's not forget that it's there, but let's focus on the part that's a problem. Tangent squared beta. Remember what I said at the beginning is look for ways to simplify, and one of the ways is to write it in terms of sine and cosine. So sine squared beta divided by cosine squared beta plus, and then instead of 1, we need a common denominator. So instead of 1, we're going to have cosine squared beta over cosine squared beta. Okay, so looking at this, since I've got common denominators, I'm just going to have the 1 fraction. And on the top, sine squared beta plus cosine squared beta. Hopefully you're getting used to this by now. But sine squared beta plus cosine squared beta is 1. So now I need to do the square root of 1 over cosine squared beta. That is equal to 1 over cosine beta. And then don't forget we've got the 5. And that's equal to 5. 1 over cosine is secant beta. And that is the answer. That is what this mess right there is equal to. So let's write that. Equals 5 secant beta. Okay, you should now be ready to do the lesson. Be on the lookout for a Pythagorean identity. The cosine squared plus sine squared equals 1. Watch for writing everything in terms of sine and cosine. And remember things about factors and terms. Okay, look for ways to factor, look for ways to simplify. Remember to watch for your terms. And good luck.